Guys, hello everyone. Welcome to Unacademy, all of you. So, in this session, we are going to discuss the important reactions of the amino acid. This is your lesson number 2. We have already had one session on the. So, what are we going to talk about basically in this session is we are going to discuss the important reactions of amino acid, right? The ability of different protecting groups to react with amino acids, also the different methods of degradation or sequencing of amino acids, because that is what is being asked mostly in your CSIR net and gate examination from the amino acid, right? So we are going to do that only. Also guys, I am an educator on an academy CSIR UGC net plus verified educators, right? Also I have 4 year of teaching experience and I have qualified all India rank 11 in the CSIR net examination, as well as all India rank 240 in the gate exam, right? So if you want, you can just visit my profile for all the important plus courses as well as all the free sessions. All your free sessions are going on completely on practice. You can check them out as well. Also, a very nice offer is going on an academy right now, 20% off by using the referral code, that is Jagriti S Live. So this is my referral code. You can use this code to get the 20% off on the Unacademy subscription, and the validity is only till 30th. Okay. All right. So what is the recent course which is going on Unacademy is organic and inorganic complete course. So we are going to discuss all the important topics of organic and inorganic. The course has already started from June 22nd, so you can just join right now using this. Also, if you want to join me on Unacademy on Telegram, you can join me. You can find me in this group CSIR net 2022. Right, this is my group on the Telegram channel. You can join up for all the important notifications about the classes and all the important notes. Also, as I have told you, special class Battle of Pole is going on. This is every day 6 p.m. on Unacademy, and if you haven't already joined, please do. Are very beneficial classes for your CSIR net preparation. Okay, so we are going to talk about a very important, directly very important reactions which have been asked. So first of all, we will see that how can you protect the amine group of the amino acid. So first of all, we are going to do the amino acid protection. Okay. So first of all, guys, how do you do the amino acid protection? Very simple method and very nice. You can correlate with this very easily. That is, first of all, I'm doing the acylation. Let's say this is my amino acid, for example, alpha amino acid. This one is alanine, sorry, phenylalanine. Okay, CH2PH. Yes, in the previous session we have done all the classification of the amino acid. You can check from there also. Or you can write this molecule in this way, in a better form. If you only want to just see what's going on, you can write it in this way, that this is your CH2, this is your CH, NH2 and COO. Alright, yes, very plain and simple. So you are going to take, let's say, acetic anhydride AC2O, alright, and you are going to do the reflux. Acetic anhydride AC2O and reflux, you are going to get the protection of the amine group. NH C double bond O CH3. This is what you will get. Okay. So first step of protection is by simple acetic anhydride and reflux, you are going to get the molecule. Also, what after this, guys? Let's say we also have one more method of protection. Very simply, you can take the oil chloride, that is R C double bond OCl. Now this R could be a phenyl group or some alkyl group, right? And it is just going to protect the molecule the same. right? This is your NH, carbonyl, and R. Okay, so you can do the acylation by taking the acetic anhydride or by simply taking acyl chloride like this. Okay, very very simple. Third, very important way of protection of the amine group is by reacting it with CBZ group. Okay, so how are you going to do that? Let's say I am reacting my molecule. Let's say I am having the same phenylalanine. Okay, you can carry this reaction out with any other amino acid as well, and I'm reacting my molecule to this COCl over here, let's say. So this nitrogen is going to basically attack on the carbonyl, and the Cl is going to get eliminated, and you are once again going to get the amine group protected. This is NH, C double bond O, O, CH2, PH. Now this whole group is basically your nitrogen carboxy benzyl group, and here I will call this carboxy benzyl chloride, CbZCl. So it is reacting with carboxy benzyl chloride. You can also write it like this, BnOCOCl. What is Bn? Bn is the benzyl group, that is CH2PH group. This group is the benzyl group. Okay, yes. So BnCOCl is your carboxybenzyl chloride. Once you react your amino acid with this, you are going to get this kind of a molecule. And what do we also write this molecule as? We can also write this molecule in this way, NHCbZ. Why do we call it carboxybenzyl? Because see, this is a carbamate system that you are having. This is a carbamate ester that you have, but it is substituted on the oxygen side, carbamate ester, so hence it is stable. All right. Yes, so this is your carboxy benzyl group, CBZ group. Okay. Yes. Fourth one, again very very important and very frequently asked also, is your Bock protecting group. Okay, Bock protecting group. How does it work? Let's see. So you are going to react your amino acid with the Bock anhydride. How do you write the Bock anhydride? BOC pole to O. Alright, and how does it look like? It is butyloxycarbonyl, right? So there is your Bock anhydride group. This is butyl oxycarbonyl, and since it is the anhydride, I'll repeat this whole thing with this oxygen over here in the center. This is your Bock protecting group. Okay, and let's say my amino acid is alanine, for example. I'm deliberately taking simple amino acids so that we can only focus on the protecting groups. Alright, let's say this is your amine group and it is going to attack over here. The good leaving group would be this oxygen from over here. Okay, yes, because it can do the resonance. So this is CH3 NH double bond O, O, 3CH3 whole twice. So what is this, guys? We are going to call it the Bock group. Group Y. This is your butyl oxycarbonyl. So butyl oxycarbonyl is your Bock protecting group to this amino acid. Alright, very very simple. Now one more protecting group that we want to do, and which has been asked in various different examination, is your fluorenyl methyloxycarbonyl. Very important and easy. Fluorenyl methyloxycarbonyl. Alright, so this is your CH2, once again methyl oxy and carbonyl over here. Now comes the nitrogen, and let's say I have taken CH2PH, I have taken alanine once again. Okay, so this is your F-MOC protecting group. F-MOC protecting group. So how do you do the protection? It's very simple. You can, over this carbonyl, you can take a F-MOC Cl. You can take F-MOC Cl. The Cl could be removed. replaced by the amine group, and this is what you have. The molecule is already protected. Also, it's very important, and the deprotection of this reaction in this FMOC group is a little bit different. Why? Because usually when you are doing the deprotection, you do it in the presence of acid. These are all amides and basically carbamates. So carbamates can dissociate in the presence of acid, and especially for the BOC group we have to take a very strong acid, so it could be the triplic acid also, right? And it is going to give the deprotection. The whole group is going to break down and you just have your amino acid. Okay, this is possible. Now in the presence of FMOC group, guys, you're not taking an acid, you are taking a base for deprotection. Why? Because there is a proton right over here. Now this proton is considered to be acidic because when the base attacks over this proton, and what does it do? It forms a carbanion. The FMOC group will form a carbanion which is going to be aromatic in nature, or at least very highly resonance stabilized in between the two phenyl groups. Very highly stabilized in between these two phenyl groups, and now the carbanion is going to fall on this carbon. The bond is going to open up, carbon dioxide eliminates, and you get back your amino acid, which is this part. Okay, so FMOC protecting group is also very important, and it is deprotected in the presence of a base. Alright, this is what we can say. Now guys, we are going to move onwards and we see some really important reactions of amino acid sequencing because they have been asked plenty of times. So we need to understand this. Let's start with the N-terminal degradation. Alright, yeah, N-terminal sequencing we can call it. N-terminal sequencing of amino acid. Okay, so first one is Edman degradation. Edman degradation method. Okay, so what happens in the Edman degradation method, guys? It's very simple. You are using phenyl thioisocyanate. All right, you are using phenyl. You can call it thioisocyanate or isothiocyanate. Okay, which looks like this: PH N double bond C double bond S. We use this molecule to break down the nitrogen side, or let's say the left side amino acid of the whole peptide chain. So guys, if you want to see how a peptide is written, what are you going to do? You will first of all write a free amine group, and then you will take the R group over here, and you will take the carboxylic acid on this side. You won't write the OH, you will write another NH group. Okay, and you will take another R dash group over here, C double bond O, one more amide linkage, one more R double dash group. Let's say I have formed a tripeptide. This is a tripeptide molecule. Okay, since we are having alpha amino acids, both the NH2 and the COH are going to be on the same carbon in this way. Alright, in this way. Yes. And let's say all the R groups are different to give you different amino acids. Now, this linkage that you have, you call this the peptide linkage or basically an amide linkage. Okay, and we want to break this down. A peptide linkage is basically inert, and that is why all the peptides in our body which make the protein are very stable, right? So the amide bond is of poor reactivity, and the left side amino acid, let's say this is our left side amino acid, we call this the N-terminal amino acid, and this is your right hand side of amino acid, this one, break from here. This is your right side amino acid. This is going to be known as the C-terminal amino acid. Breaks down the C-terminal amino acid. We have studied this in the bioinorganic. It is carboxypeptidase. Okay, carboxypeptidase, your zinc containing metalloenzyme. All right. Yes. So we want to break the N-terminal amino acid, and we are going to see how the Edmond degradation works. Okay. Let's see it in this slide. So you are having PH N double bond C double bond S. This is how it's going to work. And usually, all right, let's write it over here only how the reaction is taking place. Since the carbon is electrophilic in nature, the amine is going to attack on this carbon and the bond is going to open up on the nitrogen side. Okay? Yes. And the connectivity is going to be in this way. There's your pH group. There's the NH. Let's say the nitrogen has taken away a proton. Let's say there is carbon double bonds with the sulfur, and once again the same thing. Proton loss from the amine, you have the same peptide bond R dash, R double dash, like this, and so on and so forth. Amino acid, last one. Okay, so now what happens is, guys, how is the N terminal bond going to break? This double bond with sulfur, it is going to attack over this carbonyl, and you know that sulfur are naturally good nucleophiles because they are more polarizable. So it is going to attack over this carbonyl, the bond opens up, fall back, and the amine group is going to eliminate. So you are going to basically get this kind of a molecule at first. All right, and definitely this nitrogen is going to assist in doing so. So this is what you get. Sulfur has made a bond with the, this is going to be a 5-member ring, 1, 2, 3, sulfur. All right. So this is going to be a 5-member ring, a carbon and nitrogen double bond, sulfur, and this side you are getting this carbonyl. It has been attacked by the sulfur. This side you get the R group. You are going to get the 5-membered ring over here, and the remaining portion of the amino acid, let's say remaining 2 amino acid peptide, dipeptide, will be eliminated. So this is what you get. Also, when I am providing acid, to this system, this is not yet the whole product. To this system, when I provide the acid, the molecule is going to open up. You are going to get carbon, double bond S, once again NH and R group, and free acid molecule. So water is going to attack on this system and the bond opens up from this side. You can directly write it in this way and you form an open chain structure. Once again, it is going to close the ring, it is going to rearrange and the ring is going to close to finally give you this phenyl hydantoin. Okay, so you are going to get the phenyl thiohydantoin. That is also once again a 5-membered ring only. So you write double bond S over here, NH group, R group, and the carbonyl. Okay, now this is your final product of the Edmond degradation, phenyl thiohydantoin. And in your previous year examinations, it has been asked a lot of time. All right, how would you recognize that which amino acid is present? So in your questions, what will be asked is, let's say the question is telling you that after steps of amino acid sequencing, after 2 steps of amino acid sequencing, you are getting this kind of a molecule. Okay, this is, let's say this is the first molecule that you have got on the amino acid sequencing. So what would you say, which acid is present on the N terminal? So guys, it is very very easy to understand that if you understand that this is coming from the phenyl thioisocyanate, because this was the starting material that we had used, isn't it? From the structure of phenyl hydantoin, thiohydantoin, very easy to break down. This is NH2, this is the COH group side, this is your alpha amino acid. Okay, so very directly from this structure you can identify. So from here we see NH, CO double bond OH, CH2PH. The amino acid that you have is phenylalanine. Okay, so it is very easy to identify that what is going to be the amino acid which has broken down from the N side, because it is basically removing this from the left hand side, which amino acid was present on the left hand side or on the N terminus, phenylalanine. Okay, so this is how you're going to be able to recognize based on the Edman degradation. One more important method of degradation is Sanger's method. Okay, and what is the reagent in the Sanger's method, guys? You are getting 2,4-DNFB. What is that? 2,4. Very simple. All right, you are getting 2,4-dinitrofluorobenzene. 2,4-dinitrofluorobenzene. This is your Sanger's reagent. What is going to happen to this? Once again, I am having let's say I'm having this kind of a molecule, or in the place of R, let's say I write CH3. That is going to give me alanine, and here I write CH2PH double bond O. That is going to give me phenylalanine, and over here I write CH2 CH2 SCH. That is going to give me cysteine. Alright, like this. So what I'm doing is I am reacting this tripeptide. What is this tripeptide, guys? It is ALA, T, that is alanine, phenylalanine, and cysteine. This is the tripeptide. Whichever amino acid is present on the left hand side, you will write it first. Okay, so what I'll do is I will break this molecule down. I will make the reaction happen. Degradation from the N terminal. So this amine group, the phe amine group, is going to attack on this position, ipso attack, because since this is an electron deficient molecule, the electron attack is going to be very much feasible. So you are going to get this whole molecule broken down. Let's say I will first connect this DNFB molecule. So I'm directly connecting. How would you connect this DNFB molecule? Or let's say directly connect the fluorine position, the SNAR substitution nucleophilic aromatic has already taken place. This is your molecule after the nucleophilic attack. Now I will do the acid hydrolysis. Okay, and since it has got connected to such a big group, the bond is going to break from here. The left amino acid has eliminated along with the DNFB molecule. Okay, so this is what you get, NH, COOH, and CH3. The left molecule, left amino acid has eliminated, and you are going to get a yellow color complex. Okay, so let's say particularly for this you are going to get a yellow color complex. So when you get the yellow complex, you are going to understand that yes, your reaction with the amino acid has happened and one amino acid has been sequenced. Okay, so you are breaking this molecule down in this way. And what happens to the rest of the peptide? In the presence of acid hydrolysis, all of the peptides are going to break into amino acid. But which one we will detect? The one which is connected to NFB, that is the N terminal one. Okay. Also, we have one more method, that is, we call it as the Dancil chloride method, या फिर Dancil method. Yes, what is this method, guys? Dancil method. It is basically we are using the Dancil chloride, and it is a very highly fluorescent molecule. Highly fluorescent molecule. Okay, and yes, let's see. Your dancyl chloride, guys, S double bond O double bond O Cl. All right, and this side you are having this molecule, right? This group attached. So basically, you can see that the molecule is very rich in conjugation, and that is why highly fluorescent. What will happen is, as you can see, guys, you can see the amino acid, the N terminus of the amino acid that can directly attack over the sulfonyl and replace the Cl group. And then what is going to happen with the amino acid? Let's say I'm writing the whole molecule as it is. We have connected this with the amino acid, let's say, and the hydrolysis has been done, for example. So there is the N-terminal amino acid, only the N-terminal amino acid coming up with the sulfonyl group NH, C double bond, C double OH, and let's say this was your R group, whichever amino acid. The N-terminal amino acid has broken down and connected to your dancyl group, and this is going to be highly fluorescent in nature. So the fluorescence of the amino acid, particular amino acid, this is identified, and hence it is identified that which amino acid is present. Okay, so this was very, very important, and plenty of times it has been asked in the CSIR NET and GATE examination. There is also one more example, which is also a test for amino acid, that is the ninhydrin reaction. Very recently also it has been asked, ninhydrin reaction. What is the ninhydrin reaction, guys? Let's see. Ninhydrin reaction is, you are taking this kind of a molecule, alright, okay, two of them, and you are reacting your amino acid, or let's say the peptide, this molecule. Now at basic pH is equals to 9, let's say. At basic pH, using the amino acid, it is going to make a complex, and the complex is going to be like this, let's say. Using the amino acid, it is going to make a complex. You have to remember how the structure of the complex is, because this time the structure was asked, right? So this is going to be the exact structure. You call it Ruhemann's purple. And the wavelength of this color, it is 570 nanometer. Alright, along with that, you break down the R group as well as CO2. So what just happened, guys? This molecule is going to only take away the NH2 group, and the RCH part is going to get oxidized to RCHO, that is your aldehyde, and the COOH is going to get eliminated as carbon dioxide. Okay, so you're only using the NH2 of the acid. This is also a test for the detection of the amino acid, and if you get intense purple, या Ruhemann's purple color, you are 100% sure that you are going to have the amino acid. Okay, yes, so all amino acids will react with will react with 2 moles of ninhydrin, to give this intense Ruhemann's purple color product. Lekin there are two more there, whereas there are two amino acids, proline and hydroxyproline. So hydroxyproline is just a derivative of proline, the essential secondary amino acid that gives you yellow color. Okay, so just in case the question is asked, because it is different, makes an exception. So proline is going to give you a yellow color on the reaction with ninhydrin molecule. Okay, so yes, guys, we have understood some really important concepts based on the amino acids, and we are going to do questions on the amino acid, but Those questions will be done in the special classes. Okay, here we are only doing the theory. So if you are liking these sessions, then please visit the special classes too. And I would also suggest you that if you already haven't subscribed to the channel, please do like and share the content. Bye everyone. Have a nice day, all of you. I'll see you